Welcome to the Health AI Brief, breaking down the AI shaping our world one concept at a time. In the last episode, we explored how AI can learn from imperfect data. Today we're focusing on a related and equally important theme, efficiency. So training a state-of-the-art medical AI model can require immense amounts of data and expert time, but what if we could make some smart shortcuts? We're going to break down two powerful techniques designed to make the AI training process faster and more resource efficient. They're called transfer learning and active learning. Let's start with a simple premise. It's easier to learn a new skill if you already have relevant background knowledge. You don't start from zero. This is the core concept of transfer learning. Imagine you want to train an AI to detect diabetic retinopathy from retinal scans. You could start from scratch, or you could start with an AI model that's already been trained on millions of general purpose photographs from the internet, pictures of cats, cars, landscapes, and people. While that sounds unrelated, that pre-trained model has already developed a sophisticated visual cortex. It's learned to recognize fundamental visual building blocks like edges, gradients, textures, and shapes. Transfer learning is like hiring this photography expert to give them a crash course in ophthalmology. Their brain's already wired to see. You just need to fine-tune their knowledge on a much smaller, specific data set of retinal scans to teach them how to apply that expertise to spot things like microaneurysms and hemorrhages. This method gives the model a massive head start, dramatically reducing the amount of medical-specific data and training time required to achieve high performance. The second technique addresses the most valuable resource of all in medicine, the expert clinician's time. If you have a few hours with a world-class radiologist to label data, how do you make every minute count? The analogy for what's called active learning is a highly efficient smart study group between an AI model and that expert radiologist. The process works in a loop. First, the AI trains on a small initial set of labelled scans, then it analyses a huge pool of thousands of unlabelled scans. Instead of guessing randomly, it intelligently identifies the 20 or 30 cases that it's most uncertain about, the ones it finds most confusing or ambiguous. It then presents only these hand-picked, challenging cases to the expert radiologist. The radiologist provides the correct labels. To this new, highly informative data is then added to the training set, and the model retrains. This cycle repeats. The key insight is that the expert's time isn't wasted on easy, repetitive cases. The model could already get those right. They're focusing on their brain power on precisely where it's needed most, allowing the model to learn much faster and with significantly less manual labeling than a traditional approach. And there you have it. Transfer learning gives an AI a running start by leveraging prior knowledge, while active learning ensures that our human experts are used in the most effective way possible. Together with the methods we discussed in the last episode, these techniques form a powerful toolkit that allows us to build better, more robust medical AI faster and more efficiently than ever before.